Okay, in this video, we're going to extend this idea of polymorphism in an additional direction. And it's with the idea of an abstract base class. So sometimes when you're writing code, you want to express that certain pieces of code share, common functionality. So we've already written a rectangle and a square class, and we said that a square is a rectangle. But maybe we decide we also want a circle object. But a circle object is not a rectangle or a square, but clearly it shares some commonality with a rectangle and square. They're both shapes, right? And maybe they all of these objects it might be you could calculate their area. And so that implies that we want a different kind of object that they could all inherit from. That would imply that they're all related in some way, like they're all going to have an area function. And so we might end up with a class diagram, something like this. So we have square that inherits from rectangle, we have rectangle that inherits from shape, and we have circle that inherits from shape. And then maybe we would have a base class called shape that would specify that it contains a virtual function called area. So that if we have a bunch of shapes in an array or a list, I could invoke the area function on any of those shapes to find out how much area all of the shapes in that list were taking up, or something like that, right? And because it's a virtual function, if I call the area function on anything that is a shape, it will actually call the overridden function in the derived class, right? So that'd be a pretty neat thing to have. So this class hierarchy makes a lot of sense. Rectangle and square are a kind of shape. Circle is a kind of shape, but squares and rectangles aren't circles, obviously. And so this diagram, with all of it based on shape, provides a nice context for us to think about these different kinds of objects. But there's one kind of weird thing about this. What is a shape object? Like, would it make sense to be able to have a variable that's actually a shape? It makes sense for me to have a shape pointer that's referring to a circle or a shape reference that's referring to a rectangle. But does it really make sense to have an object that's actually of type shape? Should I be able to declare an object of type shape and use it like S? What does it mean to just be a shape, right? What's the area of a shape? It makes sense to ask what's the area of a rectangle, but it doesn't make sense to ask what's the area of a shape. So really shape only exists to bridge lots of ideas, to say there are these things that there are these multiple kinds of objects that share this kind of abstract idea in common, that they have an area, right, or a perimeter, or whatever we want them to have. Shape is really just an abstraction. It's an idea. It's not a real thing. And so having this class to just represent shape is weird in that regard. And we might like for programmers to understand that that shape isn't something they should directly use. It's only something they should inherit from and derive from to make shapes that really are meaningful. Okay, and the way we express this notion that some objects are really just ideas of how to make other objects is with an abstract base class. And an abstract base class is a base class that can never actually be instantiated. You can never declare a variable that's of the type of an abstract base class. And the compiler will enforce that. And the way you say that to the compiler is by making a virtual function that has no implementation, and that for which you're not even going to provide an implementation. And the way we say that to the compiler is by putting this equals 0 at the end of a virtual function. So it has to be virtual, and then we have the normal name of the function, and then we say equals 0. And this tells the compiler that this is a pure virtual function. It's a virtual function that will never be implemented for the shape object. But when we derive from the shape object, we need to implement it, okay? If we want that class to be useful. Now we don't have to implement it, but if we don't implement this function in a derived class, that derived class is also an abstract base class and also cannot be instantiated. So until we implement this function, the class can't really be used for anything practical other than as a base class pointer to refer to other objects that inherit from it. Okay, so we make anything that we want to be an abstract base class, we just simply need to put inside of it a pure virtual function. And usually we don't think of it that way. We think of it as, well, every shape object should have an area function. But since we don't want since the shape object isn't something we're ever going to directly construct, then inside the shape object, we simply have a pure area function, pure virtual function to say that if you want to be a shape object, you need to be able to implement the area function. That's kind of the idea. But until you implement the area function, then you're still just an abstract shape of some kind. We can always spot a pure virtual function by identifying this equals 0. If you see equals 0 on any function in a class, that means it's a abstract base class. And it means that you can't directly construct it. You can't instantiate it. It would be a syntax error. You have to derive from it and specialize well, you have to derive from it and override this function to make it legal to instantiate. Okay, another way of saying all this, abstract base classes must contain at least one pure virtual function. Okay, here's our code rewritten with the shape class. I've only showed you a diagram so far, but here's what it would look like. So I'd have the class shape, and then I would have my pure virtual function for area here. And then rectangle would inherit from shape and would override area. And note, I don't need to repeat virtual here because the compiler knows it's virtual. And then for circle, I would also inherit from shape, and inside circle, rather than width and length, I would have a radius. And then the area function for circle would multiply pi times r squared. And now circle and rectangle are both shapes. Obviously, circle is not a rectangle, rectangle is not a circle, but they're both shapes. And I could use a shape pointer to refer to either one of these kinds of objects, either a rectangle or a circle. And then when I called the area function on either one of them, I would, because of polymorphism, I would use the appropriate area function. Okay, so in summary, any class with at least one pure virtual function is an abstract base class. Abstract base classes have may have other non-pure virtual functions and regular member variables and member functions. The only rule is they have to have at least one pure virtual function. Again, a pure virtual function is a virtual function that at the end of the declaration includes that equals 0. And that equals 0 here is just a special notation that means we're not going to implement it. Only derived classes are allowed to implement it. A derived class that chooses not to implement a pure virtual function remains abstract and cannot be instantiated. And only a derived class that implements all of the ABC's pure virtual functions can be instantiated. Abstract base classes kind of come into play when we want to create some sort of common interface that a lot of objects are going to use. And then you might not implement all of the pure virtual functions right away because you're going to create more of an elaborate class hierarchy, a lot of classes that inherit from each other, and in order to create some interesting relationships among them. And this will become more concrete, less abstract as we go along, but abstract base classes are kind of an important part of inheritance and polymorphism that we're going to build on top of.